Welcome to week 3, and this week we're going to go over lab 3. We're going to go over some of the questions. We're going to talk about system of linear equations and matrices. So first I'm going to start with the first two, number 1 and number 2, and we're going to solve those systems by elimination methods. So it doesn't matter which one, both of those equations we have to do the same way. So I'm going to start with the first one, number 1. So looking at my first equation, the second equation, I can eliminate x or eliminate y, doesn't matter. I'm gonna start with x. So the top x is 3, the bottom x is 1x. So if I multiply the bottom by -3, the second equation by -3, 3x minus 3x is gonna be 0, they're gonna cancel out. So I'm gonna copy the first equation, 3x plus y equals 11. And multiply the second by -3, and then minus 6y equals -21. Now when I add the two equations, 3x minus 3x is 0, and then we have 1y minus 6 is -5y equals 11 minus 21 is -10. We're going to divide by -5 both sides to get y equals +2. So that's your y. And then you can do different ways from here. You can plug it back in one of the equations, y is 2, or you can eliminate y to get x. So what I'm doing, I'm gonna use this y2 and plug it into the second equation. So I have x plus 2 times y is also 2 equals 7. Then 2 times 2 is 4, so I'm gonna subtract 4 in both sides, and that will cancel out these numbers. So I'm gonna get x equals, subtracting 4 both sides is gonna be 3. So x equals 3, y equals 2. When you put your answer, make sure the first place is x, so it's gonna be 3, 2. That's how you enter that answer. So that's a review from algebra, solving linear equations, system of linear equations. The same way we're going to do the second one. We have 6 and 3. If you want to cancel x, you're going to multiply the first one by -2, and it's going to cancel the x. And then if you do that, it's going to be -6x minus 8y equals +40, and then copy the second equation equals 20, and then when I add them, this cancel, so I get 0 equals 60. 0 equals 60 is not true, so the system have no solution, and that's what you're going to put here. You're going to put inconsistent. You're just going to spell it out. Okay, so the first answer here was 3, 2, and I'm going to check that. And then the second answer, we have to type it in inconsistency. That was right. And here we're just going to put inconsistent because, make sure you spell it inconsistent. We have to spell it correct because if you misspell it, it's going to be wrong. Okay, so that's it. So that's how you solve the system of equations. Now the next, number 3 and number 4 are the same way. You're going to set up a system of equations and you're going to solve it. So I'm going to help you here just to set up the system, and then you can solve it the same way. So I'm not going to solve them. I'm just going to set up the system for you. So number 3, we have to formulate a system of equations. We have to set up your system, and we have to solve it. So here x represent nickels, y represent dimes. So we have a jar with 70 nickels and dimes. So that means when I add x plus y, the total number of dimes and nickels is going to be 70. That's my first equation I'm going to use. Okay, now the second equation is going to be, we're going to use the money amount, which is the worth of the money, of the coins. How many of each coin are in the jar? So I need to find x is the nickels, y is the dimes. So now if it's $5.30, you know that one nickel is 5 cents, right? And one dime is 10 cents. So if I multiply 5 times x plus the dimes are 10 cents times y is going to be equal, now the money amount is given in dollar amount. I'm going to change $5.30 is 530 cents. So $5.30 is 530 cents. You can work it out like this, solve the system, and then the answer is x is whatever number you get and y is whatever number you get. Okay? And I'm not going to solve this because it's the same way we just did number 1 and number 2. You can eliminate x, eliminate y, and then find everything else. Now, the next one, number 4, is the same idea. So here we have to set up a system. We have a concession stand at ice hockey rink received this. So this is the amount from selling total of sodas and hot dog. So we have x is the sodas, y is the hot dogs. So when I add x plus y, that's the number of sodas, number of hot dogs, is going to be 4,200 is the total number of sodas and hot dogs. Now we're going to use the money amount given the same way we did before, but we know here each soda is $2. So soda is x. So 2x plus each hot dog is $3 sell. So it's going to be 3y equals the total amount, and everything is in dollars, so it's going to be $10,200. So this is the system you have to solve. The same idea, the same way. Okay, I'm not solving it. You can eliminate x, eliminate y, and find what is x, what is y. Okay, so that's how you solve system of equations. Then the rest of it is system of matrices, and here what it is. This is what it is. It's really easy. Okay, so what is a matrix? Matrix is like a table. So look at it like a table of numbers. Okay, so this table here, looking at this matrix, what is the dimension of the matrix? So the dimension is always represented with row by column. So how many rows are in this little table? So the table has, so this is 1 row, 2 row, 3 row. So it's going to be 3 rows by how many columns are here? So the columns is going to be just going down. 1 column, 2 column. So 3 by 2, that's the dimension. That's it. So you're just going to put 3 by 2. 3 rows, 2 columns. That's it. Now, also they ask you to find what is A11. So A11 means the element in the, so I'm going to put A1 and 1. So the first number here represents which row is the number, and this is the column. So I'm going to go in the first row, in the first column, and see what is the number there. So first row is here, and first column is here where they meet. They meet in this number. And what is the number there? It's 2. Okay? And the next one is, they ask me what is A3 and 2. So that means I need to go third row and second column. Third row is here, and second column is here, and they meet at this number. And the number there is 9. So that's what you have. I'm going to put 2 and 2. And the second one is 9. Okay? You do the same with number 6. How many rows? We have 1, 2, 3 rows. And how many columns? 4 columns. Okay, the same idea. So you have we have 1, 2, 3 rows. And you have 1, 2, 3, 4 columns of numbers. And then we need to find A22. So A2 and 2 means I need to go to the second row and the second column. So that's going to be this number here, which is 7. And then we have also to find what is A element 3 and 4. So I'm going to go to the third row, and the fourth column is going to be this number, -6. So I have here, it's the number is 7, and the other number is -6. That's all. You're just looking at the given numbers, looking at the table. Okay? So that's how you do this one. Finding the dimension of a matrix. Matrix is a little table of numbers. That's all what you have. So let's submit and check those answers. Okay. Now we need to submit everything individual. Okay. The next one is, we have, okay, there you go. So the next one we're doing number 7 and number 8. We have to transfer this system of equations to a matrix. So this is how you do that. And why you do that? You're transferring system of equations, the way you solve number 1, number 2, you're solving it, right? You know, elimination method. Now, there are many more methods of solving system of equations. There's a class of math which is called linear algebra. So there's a separate class where they just solving system of equations, a lot of methods, a lot of equations, and it's called linear algebra. So here, when you have more equations in number 8, you have 3 equations and 3 variables. Instead of x, y, and z, they have x1, x2, and x3, okay, which the same way represent 3 different variables. So if I want to solve the system in another way, you can set up this, you can transfer the system. If it's more complicated and bigger system of equations, you can transfer it to a matrix, and then you can use computers to solve it. That's the idea behind this. And the computer is solving it really fast. So instead of solving it by elimination, if it's bigger system, you can transfer this system to augmented matrix. That's what it's called. And the augmented matrix is just a little table from the system. And this is how it goes. So the first column is going to be all the numbers in front of x. The second column is going to be all the numbers in front of y. Then you have this vertical line which represent the equal sign. And then you're going to have the numbers in the other side. I'm going to just put a symbol for numbers. And this is how you transfer this system. So it's going to be the top is 2 in front of x, then -4 in front of y, and then it's going to be equal 18. So this is going to be the first row in that matrix in this table. And then the next one is going to be x, so it's going to be 1x. See, that's the equation, x equals 8. Now, there is no y in the second equation, so I'm transferring the second equation. There is no y, so it's 0. You're going to put 0. And then the number in the other side is 8. So this is how you're going to transfer your system of equation to an augmented matrix. You're just going to put the numbers there. So the numbers are going to be 2, -4, and 18. You just go row by row, equation by equation, put it in the system. And then you're going to have invisible 1 in front of x. There is no y in the second equation. That's why I put 0. And it's going to be equal to 8. And that's how you do this one. Okay? Now, the next one, the next system, getting from the system, go to the augmented matrix is going to be the same way. We're going to go row by row. So here you have the same way. It's going to be x1, x2, and x3. So in front of x1 is 1. In front of x2 is also 1. And in front of x3 is also 1. See, from the first equation, you have 1 in front of x1, 1 in front of x2, 1 in front of x3. And that's equal, the number there is 2. Then you're going to go to the second equation. You have 1, 5, and 1 in front of x3. And the number in the other side is 5. And then you're going to go to the third equation. You have 1 in front of x1, 3 in front of x2, 2 in front of x3, and that's equal 5. And that's it. That's all what you're doing. You transfer the system of equations to augmented matrix, to a table. Okay? So that's all. That's all what you're doing. Okay. And then when you put that system to a matrix, the computer is going to solve it. And after you solve it, the solution is going to look like number 9. So you look at number 9. This is your augmented matrix, right? But this is important. In front of the equation, you have, in front of the matrix, you have, it's called unit matrix, which means you have 1, 1, 1 in diagonal, and everything else is zeros. So if you have matrix like this, it's called row reduced matrix. This is row reduced matrix is called. And if you have it like this, the solution is right here. These are the numbers for your solution. Because if you think back, if I want to transfer this matrix to a system, it's going to be x1 equals 7, right? The second one is going to be x2 equals 8, and x3 equals -6. And that's your solution. So the solution, you're just going to write it like that. You're going to put 7, 8, -6. That's it. You just transfer the solution from the matrix. And that's the answer. And then we have few more operations with matrices. So we have matrix A, which is number 10, which have the dimension 3 by 3. And we have to find AT. AT means we're going to transfer row to column. So this is how this goes. So the first row in matrix A is going to be at the first column in the AT matrix. So we're just going to change the number. So it's going to be row, change to column. So it's going to be 9. You're going to put 9 and 1 down here. And then you're going to go to the next row. The next row is, I'm going to use different color, is 119. See 119, and you're going to transfer it into the second column. So you're going to put, so row transfer to column. So it's going to be 1, 1, and 9. And then do the same with the bottom, with the last one. So it's going to be 6, 7, and 9. That's all. So this is operation with matrix. Just change it, row to column. Okay, nothing else. Now the next one is another operation with matrix, which is we have the matrix C, which have dimension 3 by 3, and 3C, I mean this is the number here given, 3 times C, means you're multiplying the matrix C times the number 3. And what you do when you multiply all the numbers the way they are by 3. Okay, so the first number is 1, and multiplied by 3 is going to be 3. You can go row by row, column by column, doesn't matter. 3 times 7 is 21. 3 times 6 is 18. And then you have 3 times 9 is 27. 3 times 8 is 24. 3 times 5 is 15. You just multiply. 3 times 8 is 24 again. 3 times 4 is 12. And 3 times 1 is 3. And that's it. You just multiply each of the given numbers and just keep their places. Don't move them. Just keep the places there. Just multiply each of those by 3. That's all. Okay, the next one is number 12. It's another operation with matrix, which is adding two matrices. So you have matrix A, matrix C, and you have to do A plus C. And this is how you do it, element by element. So you're going to add the first element plus the second element, and it's going to go in the first place here. So 7 plus 4 is 11. You're adding them. Then you're going to go to the next one. So you have 2 plus 4 is 6. Okay? Then you're going to go to the third one. So you go row by row and add it. 5 plus 6 is 11. 11. And then you can go to the second row. The first number is 1. The first number in the column, you're going like this. So we add in 7 plus 4 from the first, 7 from the first, 4 from the second. Then 2 plus 4, 5 plus 6. Then you're going to go to the second row. We have 1 plus 8 is 9. The number here, this element in the middle is going to be 6 plus 6 is 12. And then 3 plus 7 is, you adding is 10. Oops. 10. Then the next one is 3 plus 7 is also 10. 7 plus 5 is going to be 12. And then you have 7 plus 9 is 16. So you're just adding element by element. And you're just keeping it in the same place. That's it. Okay, and then the last question for this week is find the product of two matrices. So multiplying 1 and 2, which is matrix with 2 rows and 1 column, and the other one is 1 row and 2 columns. So we're multiplying element by element, and this is how you do it. So we're multiplying here the first row by the first column, and that's going to be this number here, because this number is element 1 1. Remember, we have the elements of 1 1, the first row, the first column. Then the next number is going to be first row and second column. Then the next number here is going to be second row and first column. And the number here is going to be second row and second column. So this is how the elements, the numbers are going to be in this answer matrix here. So we're multiplying first row by multiplying. 1 times 1 is 1. So this number here is going to be 1, right? Then I'm going to do A, 1, and 2. So 1 and 2 here is going to be the first row and the second column. So I'm multiplying 1 times 4 is 4. Then I'm going to go to the next one. The next one is going to be 2, 1. So I'm going to do second row and first column. So that's 2 times 1 is 2. Then I'm going to go to the last number I need to get, which is 2, 2. So I'm multiplying second row and second column. So 2 times 4 is 8. So these are my answers. I'm going to put here the first one is 1, then I have 4, then I have 2, and the last one is 8. And this is how you do it. Okay? So that was week 3. Week 3 is really easy. Now next week is the midterm exam, so don't forget, just start working on it ahead of time if you can, and just practice to be ready for the midterm exam. There is a review for the midterm exam. Work on that so you can be prepared for the midterm exam. So that's the week 3.